Hello. Welcome to my video about a TV lift cabinet. I made this TV lift cabinet for my younger brother. It is quite unique since it lifts two TVs. My younger brother is a big fan of Nintendo and has a lot of their consoles. He insists on playing the old school consoles on an old school TV. But he also has a modern flat screen TV. So he needed a TV cabinet that made it possible to use both TVs. As an engineer, I thought I could be of assistance realizing this requirement. So I thought of a few concepts for combining two TVs into a single cabinet with space for his consoles and games. The first concepts are based on a simple lift mechanism. The problem with the first two concepts is that they require a lot of space inside the cabinet if the TV is lowered in the cabinet. I wanted to leave space there for the storage of his consoles. So, these concepts are not great. So a solution would be to lift the flat screen above the old TV, but that would create a strange viewing angle if the TV needs to be that high above the cabinet. And it leaves a distracting TV in front of the flat screen. The TVs could also be rotated or flipped. But this also requires space around the cabinet and cable management would be problematic. In the end I settled for a 4-bar linkage mechanism as you see in the animation here. We can have a closer look at the space for the TV by cutting away some part of the cabinet. As you see, the space requirement in the cabinet for the TV is minimal. You will notice that the lift mechanism is tipping downward a bit. I will explain why that is in a moment. If I remove the cabinet entirely, we can have a better look at the mechanism. The mechanism is powered by a DC transmission motor at the back, which produces a high torque output. This motor is connected to a drive shaft with a keyed worm. The worm is driving the worm gear that is attached to the back arm. The worm gear has an additional transmission ratio which was needed to increase the torque coming out of the DC motor. In addition, the worm gear is self-braking. If the motor would fail for some reasons, the TVs would not crash down. And the worm gear allowed the motor to be placed at a 90-degree angle to the back arm, which was favorable to save space in the cabinet. A 15-kilogram counterweight is attached to the front arm via a pulley system. The pulley system has a 4:1 ratio, increasing the force on the front arm by 4 times. As I was designing the mechanism, I noticed the tipping of the lift mechanism. By adding the force of the counterweight at the front arm, I was trying to prevent this tipping. In addition, I wanted to relieve the DC motor somewhat by counteracting the weight of the TVs by the counterweight. Most of the parts in the mechanism are steel plates which I could order from a laser cutting company. Other parts, I machined on my MCO 7 lathe milling machine combi. As some kind of an experiment, I wanted to machine the worm gear in the back arm. I did that on my lathe by putting an end mill in the chuck and manually rotating the back arm. After the groove was cut, I changed the end mill for a thread tap and manually rotated the chuck to cut the gear. And it worked. A bolt could be used to drive the arm, but the teeth geometry was of course not great and the construction steel is not suited for this application. So I ordered a brass worm gear and machined a pocket in the back arm to attach the worm gear. I put the mechanism together and started testing. I substituted the flat screen for a 20-kilogram weight so I wouldn't crash the flat screen if anything went wrong. The assembly of the mechanism went okay, but the tipping, which I tried to prevent, did happen anyway. A little bit of manual intervention at the bottom of the movement was enough to help the mechanism to complete the motion to the top. In the video of the test, you see a mechanism doing the manual intervention. In this animation you can see how the mechanism is changed from the initial design to the final design. I removed the DC motor and replaced it with a 800 Newton linear actuator, as the worm gear was underpowered. The counterweight was not necessary anymore as its function was largely replaced by the front raising aid. The front raising aid acts on the lid at the bottom of the movement. At the top of the movement, the front raising aid is lowered again to keep it out of the view. This is achieved by a bushing at the front arm that pushes the aid down. A spring in the back of the cabinet is used to generate the force on the front raising aid. The mechanism can be set into motion with a remote or a button in the cabinet. The whole mechanism is controlled by an Arduino. Using limit switches to detect the end of the motion, the linear actuator can be stopped with relays. The motion of the mechanism is still a bit jerky, but it functions. The part that is in motion weighs almost 50 kg. So, it is no wonder that the actuators are struggling a bit. To get the most use out of space in the cabinet, I made a folding drawer. The drawer folds away when the bottom drawer is pulled out. And the folding drawer lowers again when the bottom drawer is pushed back in. There were a lot of lessons learned making this TV lift cabinet. I had a lot of fun making it. If you want to know more, please let me know.